Hello, everybody. Hopefully by now you have your Chromebook and you have logged in to GradeCam so that we can first go over the exam that you took yesterday. If you don't have those Chromebooks yet, the sub can pause the video now and you can go get them. Otherwise, we are going to get started. I wanted to first show you our class results. Okay, you can still be average here, 75%. That's a good score. That's a good grade overall. That's in the 3 proficiency range. So good job overall. If you want to dive a little deeper, and I think it's worth mentioning, this is an interesting graph to say the least. Normally when you collect data on a lot of things, particularly people, you end up with what they call a bell-shaped curve or a normal distribution. And it looks something like that, where most of the people are kind of in the middle, the average, if you want to call it that, with less people doing really well and less people doing really badly. We ended up with more of a reverse bell curve. Like we had a lot of people do really, really well, but we had a, significant number not do very well. So I don't really know exactly how to interpret this. Again, the more of us that did well is the bigger number, so that tells me that the majority of us did did well, and the majority of us knew what we were doing. But there is still a significant portion that didn't. There was clearly something missing, right? If we're in a one, that really means you don't really understand what's going on. And then, these two over here, they definitely don't. So please sign up and reassess. And I know spring break is coming and it's probably not going to get done. In fact, I know it's not going to get done until after spring break, but please reassess. Okay. And also it brings up another point. I think as a class, we can definitely do more to make sure that we don't end up in this hole in the first place. We don't need to do badly on tests and then reassess. We can do well the first time. And I know you can. You've shown me before that you can do quizzes really well. You've shown me that you know what you're doing when you have your whiteboards. I have confidence that you guys can do this. Um, but again, the tests are really the kind of the final measuring point, and we're not doing very well. So I hope that you reassess. Okay. With that, let's start going over the exam together. Okay. All right. Number one reads, choose the correctly balanced equation below. So the things we should be looking for here are, are the coefficients? Well, probably actually we should look at the subscripts first. So we're looking at diatomic molecules. We're looking at um, ionic compounds. We're looking for those types of things, but we're also looking for a balanced equation. Are there the same number of atoms of each atom on both sides? So if we look at the first option, A, I can see that there are 2 chlorines here, but only 1 over here. So A is not balanced. If we look at B, I see I see 4 nitrogens here and only 2 on that side. So that one's not balanced either. On C, I can see 2 hydrogens on both sides, but 2 oxygens there and only 1 there. So that one's not balanced either. So here's to hoping it's D. I see 4 hydrogens and 4 hydrogens, 2 oxygens and 2 oxygens. H2 and O2 are both written correctly because I know those are diatomic molecules, so I'm very confident that D is the correct answer. Sorry if you can hear water, that's my dishwasher running in the background. Number 2 reads, choose the correctly balanced equation below. So kind of the same thing. I can see A is incorrect already because it's the same equation as the correct answer from the previous question, but it doesn't have the same coefficients, so I know A is incorrect. B looks wrong on multiple fronts, right? I see H and O, which are both diatomic, but they don't have their 2 subscripts. Plus, I can see that there's not the same number of oxygens, so B is incorrect. If we look at C, these are written correctly, and there are 2 of each atom on both sides. So C does appear to be correct. D, nope, D isn't correct. There's 1H, 2H, 2O, 1O, so that's not correct. So number 2 is C. Number 3 reads the total mass of the reacting substances is blank. So we have to choose, right? This is clearly a question that is testing you on your knowledge of the law of conservation of mass, which says that in a chemical reaction, atoms are not lost or gained, mass is not lost or gained. We always maintain the atoms, we maintain our mass. We're just breaking and forming new bonds. So The total mass of the reacting is not going to be more than the products. It's not going to sometimes be more or less. It won't always be less, but it will always be equal. Number 4 reads, only blank may be changed to balance an equation. That's kind of our most important rule when balancing. We never change subscripts. We only change coefficients. We also don't want to change the identity of the reactants or products because that would make it a different equation or a different reaction entirely. All right, so 5 through 8, or maybe, no, yeah, 5 through 8, these are, I mean, you had to balance them, but I wasn't asking you to write down the whole equation. I just, you had to balance it to find what's the coefficient in front of one of the particular elements. So let's start by balancing it first, and then we can answer the question. Okay. The order in which I instructed you in class to balance equations is to balance metals first, then nonmetals, except for hydrogen and oxygen, always saving hydrogen and oxygen for the very end. Um, again, the reason is I've done this long enough that I know if you do things in that order, hydrogen and oxygen more often than not will work themselves out. So to begin, I can see 2 iron atoms on the left, that's the Fe, and only 1 on the right. So I think to begin, I'll put a 2 in front of that iron. Then to balance carbon, carbon already is balanced, so I'll leave that alone for now. And then we get to oxygen. I can see that there are 4 oxygens on the left side and only 2 on the right. And so begs the question, what do we do? I mean, there's oxygens in multiple different places, especially on the left side. So I kind of have a gut feeling that I'm going to need to change more than one coefficient. There's going to be more than one. So I'm thinking that if I put a number here, that's going to make the total number of oxygens odd, I guess, depending on the number. So I'm trying to think if I might be able to fix it by putting a number there. That's just kind of where I'm heading. I could be wrong, and it's okay if I'm wrong. I'll go back and fix it later. But I'm thinking that, I'm thinking, actually, no, I think I'm going to put a 3 right here. Because if I do that, that makes 6 total. That makes 6 total oxygens, 3 on the Fe2O3 plus 3 more, which means that I would put a 3 right here to make 6 oxygens, and not coincidentally, that fixed my carbon as well. And so I'll double check. 2 iron atoms, 2 iron atoms, 3 carbon atoms, 3 carbon atoms, 1, 2, 3, 4, 5, 6 oxygens, and 3 times 2 makes 6 oxygen atoms. And so I have a balanced equation. And so the question reads, what is the coefficient in front of CO? The coefficient in front of CO is 3. So that's your answer. All right, number 6, we have, it looks like iron 3 hydroxide making iron 3 oxide in water. We want to know what's the coefficient in front of water. So let's first balance, and then we can figure out what that coefficient is and answer the question. Okay, we start with iron first, and it appears there are 2 on the right and only 1 on the left, so I will put a 2 right over there. Then let's fix hydrogen. I count 3 times 2, so that's 6 hydrogens on the left side and only 2 on the right, so I will put a 3 in front of H2O to balance that. So then we'll take a look at oxygen. Again, I count 6 oxygens on the left and 1, 2, 3, 4, 5, 6 oxygens on the right. So we are done. This is balanced. And so to answer the question, the coefficient in front of H2O is 3. Number 7. Given the unbalanced equation, sodium plus water makes sodium hydroxide and hydrogen gas. What is the coefficient in front of H2O? Oh, same thing. First, let's balance sodium, and sodium is already balanced. Then we'll balance hydrogen. I see 2 on the left and 3 on the right. 1, 2, 3. So I'm thinking I'm going to put a coefficient, and this is kind of counterintuitive, but I'm thinking I'm going to put a coefficient on the right-hand side first, just so that number of hydrogens becomes even, and then I can change the one on the left. So I'm thinking I'll put a 2 right here first. So that makes the hydrogens 4, and so I'd put a 2 right here to balance that. But I noticed that by putting a 2 right over here, I have unbalanced the sodium atom. So I'll fix that first, and I'll put a 2 right over here. Okay, so sodium and hydrogen are both good now, and I'll check my oxygens, and I see 2 on the left and 2 on the right, which means we're done. So to answer the question, the coefficient in front of H2O is 2. All right, number 8. This iron 3 oxide and aluminum make aluminum oxide and iron. All right, so iron and aluminum are both metals involved, so we want to balance them first. So I'll put a 2 right over here to fix the aluminum and a 2 over here to fix the iron. Those are nice because they don't change anything, and the oxygen is already balanced. So we are done. So the coefficient in front of iron is a 2, so that is our answer. Okay, moving on to the next part. Number 9 says identify the correctly written balanced equation when aluminum reacts with copper 2 sulfate to produce aluminum sulfate and copper metal. I can see that this problem is not just testing our ability to balance an equation, but it's also testing our ability to recognize a correctly written formula for copper 2 sulfate or aluminum sulfate, because I can see that that right there and that right there, those are definitely not the same thing. So I've got a little bit more work to do. So what I think would be helpful first is to figure out what are just the formulas for each of these compounds. And then I can check and I can eliminate ones that don't match and then pick the one that's balanced. So aluminum metal would just be aluminum. Copper 2 sulfate, remember this 2, this Roman numeral 2 indicates the charge on that copper ion. So this is a +2. Sulfate is a polyatomic ion, and if I look at the list, it's a -2 charge. So the formula is going to be CuSO4. Normally there would be a 2 in each of these places here, but we always reduce the ratio of ionic formulas. And so the formula is simply CuSO4. So I can already tell that D is not going to be a correct answer because that's not the formula for copper 2 sulfate, nor is C. This is not the formula either. So we now go to A and B. Let's look at aluminum sulfate. The formula for aluminum sulfate, aluminum is a +3 ion, again, sulfate is -2, so the formula would be Al2, and then in parentheses, SO4, 3. That is aluminum sulfate. And so I can tell that this is not aluminum sulfate. So I don't really even need to check if it's balanced. I can pretty well tell what the correct answer is going to be. You can double check if you'd like, but you'll find that the equation is balanced. So number 10 says the following is a balanced chemical equation. The instructions say to prove that it's balanced, and it follows the law of conservation of mass. Okay, this problem is really getting at the heart of balancing equations. Why do we even bother to balance them? And that's because of the law of conservation of mass. Chemical reactions don't destroy or create matter or atoms, they simply rearrange them. So what I looked for in number 10 was a little bit of an explanation of, yes, there are the same number of each atom on both sides, and this is because of the law of conservation of mass. We don't want to add new atoms or take away old atoms. We just want to rearrange them. So as long as you mentioned and you kind of explained that the equation was balanced and you made mention of the law of conservation of mass, you got your 2 out of 2. A lot of you just kind of mentioned how it was balanced, so I gave you partial credit for that, but you never mentioned the law of conservation of mass. But that's all I looked for number 10. All right, 11 through 16, the most difficult part. But again, I am very confident that you know how to do this. You've learned most of this stuff before. It's just a matter of being careful and deliberate and making sure that we're doing everything the way we're supposed to. Let's take a look at the first one. Copper. Just copper. Copper is not a diatomic element. All right, I can write over here just so I remember it. Brinkelhoff. These are the 7 diatomic elements, and copper is not one of them. So copper just on its own can be written as just Cu. Oxygen, on the other hand, is, so I'll put plus O2. Okay, copper 2 oxide, that's an ionic compound, so I'll follow the steps of swapping and dropping. I have 2 and 2 as my charges, so I know that when I swap and drop 2 and 2, I can reduce that ratio to 1 to 1. So the formula for copper 2 oxide is simply CuO. And then I can balance it. The copper is good as it stands. To balance oxygen, I'll put it to here, and then I need to go back and fix copper, and now I'm done. So the way I graded each of these, 11 through 16, is I first looked at were each of your chemical formulas correct. So writing the correct formula for copper, that would be 1 point. The correct formula for oxygen gas, that would be 2 points. The correct formula for copper 2 oxide, that would be 3 points. And then a 4th point for balancing the equation. Now, some of you probably noticed that you may have messed up, say, for example, the copper 2 oxide. And so let's say, for example, you instead had a formula that looked like this. Okay, if I had made this mistake, then I would have balanced according to that mistake, and I would have put a 2 in front of this, and I would have been done because that is balanced, technically speaking. It's just an incorrect formula for copper 2 oxide. So what I did was, again, I gave you the points for having the formulas, but then I looked for, is it balanced regardless of if the formulas were right or not? So let's say, for example, you had this answer here. You would have earned 1 point for the correct formula for copper, 2 points for the correct formula for oxygen. You would have missed the point here, but you would have also gotten your 4th point or your 3rd point for having a balanced equation. So you would have gotten a 3 out of 4 score if this was your answer. I tried to be as fair as possible. I didn't want to penalize you later on for making an early mistake. So hopefully I did a good job. As always, with any test, if you feel like a particular problem you deserve more credit or more points than I gave you, by all means, let me know. I'll be there tomorrow, so feel free to let me know. All right, let's move on to number 12. Potassium, just potassium. Potassium is not diatomic, so that's just K. Mixes with water, so that would be H2O. To produce potassium hydroxide, that is an ionic compound. We've got a +1 and a -1. So that's easy. That's just KOH. What's the formula for hydroxide? That's from the front cover. That's how I know it's OH. And hydrogen, that is diatomic, so I need to put an H2. So that's 4 points right there. 1, 2, 3, 4 for the 4 different chemicals. And the 5th point will come from balancing it correctly. Let's see, to balance first, we'd go for potassium, but potassium looks good as it is. Hydrogen does not look good. This is actually very similar to, I believe it was number 8, or no, number 7. It's very similar to number 7. There's just potassium instead of sodium. So I imagine the coefficients are going to be identical. I would put a 2 here to fix, or to make the number of hydrogens even. I'd put a 2 here to make it 4 and 4 on both sides. Then I would go back and fix the potassium. The oxygens have fixed themselves, and we are done. So there's your 5 points there. All right, potassium chlorate. We have to be careful here. There's a whole bunch of different polyatomic ions that have Cl and O. There's ClO, ClO2, ClO3. There's a bunch of them. So we just have to be careful. Chlorate, that's ClO3, and it has a -1 charge. So this is KClO3. Okay, changes to form. So my arrow goes right there. Potassium chloride. The "ide" there indicates a monatomic ion, so it's just Cl, which has a -1 charge and a +1 here. So we have KCl. Oxygen is diatomic, so I'll put an O2. So to fix this, potassium is good, chlorine is good, oxygen is not. I can see that the 3 and the 2 are, neither one goes into the other. So I think what's the smallest number that 3 and 2 both go into, and that's 6. So I'll put a 3 here to make 6 oxygens, and I'll put a 2 here to make 6 oxygens, and then I'll go and fix the K and Cl by putting a 2 there. So that would be a total of 4 points. I'll write that down if you're interested. This is a total of 5 points. This is a total of 4. Okay, number 14, sodium hydroxide. Again, that's a -1. Sodium's a +1, so this is NaOH. Forms, so we just have our arrow, sodium oxide. Sodium is +1. Oxide, which is, again, a monatomic ion, so it's just oxygen. That's a -2. So when we swap and drop, we'll end up with Na2O. And then water is H2O. Okay, to balance, we'll first fix our sodiums. We'll put a 2 over here. Hydrogen has now 2 on the left and 2 on the right, and oxygen has 2 on the left and 2 on the right. That was easy. So this one's done. So this is a total of 4 points. Number 15, calcium chloride. Calcium chloride. So I've got another ionic compound, chloride, monatomic. So that's -1. Calcium's +2. So this is CaCl2, swap and drop. Reacts with lead 2 nitrate. So I know the charge on the lead is +2. Nitrate, ATE tells me it's polyatomic. I look it up on the table and I find that it has a -1 charge. So swap and drop would have 1 lead and 2 of the nitrate ions. So NO3 inside the parentheses and with a 2 there. The parentheses are required here. All right, forms. This looks like one of those problems where the ions just swap places. So +2 and a -1 would make this PbCl2. Calcium's +2, nitrate I know is -1, so this would be CaNO3 2. And would you look at that? I don't even need to change anything. This thing is already balanced. That's kind of nice. So that's it. And again, I did make this one worth 5 points. So if you made a mistake in a formula somewhere, but you ended up with a balanced equation, I still gave you, full credit or a point for the balance part. All right, last one, number 16. Pentane, which I told you the formula for is C5H12. Reacting with oxygen, which is diatomic, produces carbon dioxide and water. All right, to fix this one, we'll want to change, we'll want to fix carbon first, so I'll put a 5 in front of that one. Then we'll fix hydrogen, so I'll put a 6 here to make 12 on both sides. Then finally we can fix oxygen. Careful to count here, right? We have 5 times 2, that's 10 plus 6. So that's 16 total oxygens. So to balance that, I will put an 8 in front of the O2. 8 times 2 is 16. And we are done. Didn't have to use the shortcut. So that's it for that one. So that one would also be worth 5 points. One other note on 11 through 16, a few of you, you ended up with a balanced equation, but you ended up kind of, I'll give you an example. You might have put, for number 12, you might have ended up with 4, 4, 4, and 2. Technically, that is balanced, but we like to reduce the ratios as much as we can. So I took 1 point off just for that. Okay, that's the end. All right, I think we're good to go. So at this point, I should have mentioned this at the beginning of the video, but there really isn't a reassessment ticket yet because there's only one thing to reassess, and that's the whole thing. It wasn't that long of a test anyway, so you don't need to fill out a reassessment ticket. You can sign up to reassess after the break is over, but that's really the end of that. So what's going to happen now is the sub will pause the video, and you'll put away your Chromebooks, and please plug them in, please. And then you'll get your study guides out and we will go from there. So the sub will pause the video now. Welcome back. You should have your study guides open. This is page 15 in the study guide, which is just mole to mole practice. Hopefully that page is done more or less. If it's not, we'll probably have some time later to work on it. But I wanted to talk a little bit about page 11. It's kind of the next step in our stoichiometry progression. So let's take a look. Everybody go to page 11 in the study guide. All right, couple reminders. Let's start out with number 1. Number 1 says, what is molar mass? Remember, molar mass is the mass of 1 mole of a pure substance. The units of molar mass, and that's number 2, is grams per mole, or grams per mole if you'd prefer to write it like that. But also remember, we could write it as moles over grams. It's not as useful all the time, but it technically is correct. So the problems there for number 3 say to find the molar mass of each of the following. So you have some examples there. We can find those fairly easily. Why don't I have the sub pause the video here, go ahead and figure these out. Once everybody's ready, we'll come back together, make sure we got the same answers. Go. All right, if you're watching, then you figured out the molar masses for each of these molecules. These are the answers that I got, so hopefully your answers match mine. I want to return for just a second to the pancake analogy. And it won't be an analogy for long. We're actually going to make some pancakes when we get back from spring break. But remember this problem, and I've asked you this before. It says the 6 eggs in the fridge are getting old, and you want to use them all to make pancakes. How many pancakes will you make if you have enough milk and mix to make with all of those 6 eggs? And so we know we can use our fence post method. I can say that 6 eggs, and I can multiply that by the ratio of pancakes to eggs. And I know that I want to put pancakes on top, eggs on bottom, so that these eggs units cancel. And then I just put the numbers from the balanced equation. 2 for the eggs and 14 for the pancakes. Once I do the math, that's really just 6 times 7, so it ends up being 42 pancakes. Now, what if the question had an additional part to it, and it said, if each pancake has a mass of 20 grams, what is the mass of all of the pancakes that we made? Well, you can probably pretty easily tell that you're going to multiply. You would do 42 times 20. But, again, we can use a fence post to do this. I can say that 42 pancakes multiplied by the molar mass of a pancake, that's 20 grams per one pancake. The unit of pancake cancels, and I'm left with 42 times 20, which, if I'm not mistaken, would be, I believe, 840 grams. And that would be my final answer. Now, here's where this gets interesting. I did this in kind of 2 separate steps. The cool part is I don't have to, because remember, multiplication and division are commutative. They can be done in any order I want to. So if I backtrack just a little bit, I'm starting with 6 eggs. I can find out how many pancakes I'll make by using the ratio of pancakes to eggs. And then I can add another fence post. And then I can include the molar mass of the pancakes, 20 grams per one pancake. And you'll notice that the eggs units cancel, one on top, one on bottom, and so do the pancake units. And I'm left with grams. And so I could put into my calculator 6 times 14 times 20 divided by 2, and you will not be surprised to find the answer is 840 grams. The fence post method works, even if there's more than one fence post. Again, this seems kind of redundant if we're talking about pancakes, but it becomes pretty useful when we're talking about chemical equations, grams, and moles. On page 11, you'll see some steps that I've kind of written out for you, just to kind of help keep track of things in your head. Okay. I put as step number 1, kind of what we've done before, start out with what you're given and put that in the top left corner. Number 2 says to map out where you're going. Number 3 says to find mole ratios that are relevant from the balanced equation. 4 is find any molar masses that are relevant. 5, make sure the units cancel. And then 6, implied, is do the math and then write out our answer with the proper units. So let's try an example. For number 4, the first thing I'd like you to do with your partner is first determine the mole ratio of aluminum and hydrogen. We can see from the balanced equation, the 2 is here. Actually, I might have this on a slide. Yep. The 2 is there for aluminum, and the 3 is here. So the ratio would be 2 to 3. Then it says find the molar mass of aluminum. Okay. We can look that up fairly easily. I actually don't have my periodic table in front of me. I'll pull that up pretty quickly. It looks like the molar mass is 26.982. That's at least what mine says. I hope yours is the same. If it's 981, it's not a big deal. It would be grams per mole. And so this question here, part C, reads, how many grams of aluminum metal are needed to produce 2.7 moles of hydrogen gas? Well, let's follow the steps. Step number 1 would be start out with what we're given. we are starting with 2.7 moles of hydrogen gas, that's H2. Step number 2 would be to map out where we are going, okay? I know I'm starting here at moles of hydrogen gas. I know that I eventually want to end up here at grams of aluminum. Now I'm thinking in my head, I don't have a method of doing that. We know that we can get from moles of a substance to grams of the same substance, or we can go from moles of one thing to moles of something else, but I can't go from moles of one thing to grams of something else. At least not in one step. But I'm thinking in my mind, if I want to get to grams of aluminum, I could get to grams of aluminum if I had the moles of aluminum first. And I can go from moles of H2 to moles of Al. So I can see from my roadmap here that this problem is going to require 2 fence posts. So I'll draw 2 fence posts, 1 and 2. Now it's a matter of filling in what needs to go where. If I look at my first fence post right over here, to go from moles of one thing to moles of something else, the scale, or not the scaling factor, the ratio we're going to use is the mole ratio from the balanced equation. So I know that on the bottom, I'm going to want moles of H2. And the balanced chemical equation tells me that that number is a 3. I also know that on the top, again, I'm using a mole ratio, so I know I want moles of aluminum. And the balanced equation tells me that that is a 2. Okay, now I'm not going to stop. I could stop, but I'm not going to. I want to get all the way to grams of aluminum. And to get from moles of aluminum to grams of aluminum, I need to use the molar mass of aluminum. So I know that I'll put moles of aluminum down here at the bottom so that again it cancels, and I'll put grams of aluminum here. Molar mass by definition is the mass per 1 mole, and the molar mass of aluminum is 26.982. And so I have everything I need. All I have to do is plug all of this into my calculator, and I can do it all in one fell swoop. I can put 2.7 multiplied by 2 multiplied by 26.982 divided by 3, and then I could divide by 1, but that's redundant. And I get a final answer of 48 point, I'll round to 1 decimal place since the problem did, 0.6 grams of aluminum. A lot of work, but we did it. It's just a matter of knowing what you're doing and where you're going. The roadmap step right up here is underrated. If you can make a good roadmap, you'll make far less mistakes. I think we can probably do one more. I think that'll probably be good. Let's take a look at number 5. First, it says to find the ratio of antimony oxide to water. So that looks to be a ratio of 1 to 3. And then the molar mass of that Sb2O3 molecule. I'm going to look it up, but you all can calculate it right now. Looks like the molar mass is 291.52 grams per mole. Again, if yours is slightly different because your periodic table is different than the one I'm using, it's not a big deal. And so the question then reads, if 3.5 moles of water react with enough antimony, how many grams of antimony oxide will be produced? Let's follow the steps one more time. Start with what we're given. That's 3.5 moles of water. Make a roadmap. We're starting with moles of water. We want to eventually get to grams of Sb2O3. I cannot make that in one jump. I can't go from moles of one thing to grams of something else. So if I want to get from water to antimony oxide, it has to be a mole to mole jump. So I can go from moles of water to moles of Sb2O3. That I can do with one fence post. And I can go from moles of antimony oxide to grams of antimony oxide. That is definitely doable. So this fence post here is going to be using the mole ratio because it's mole to mole. This fence post here is going to be using the molar mass. And so I have everything I need. Let's get our 2 fence posts drawn. All right, I know that moles of H2O needs to go down here so that it cancels. The balanced equation tells me that the number is a 3. So up here is going to be moles of Sb2O3. You might be wondering, how do you know it's moles of Sb2O3? Because I drew the road map. The road map tells me that's what to put. Balanced equation says that that coefficient is 1. Then I'll use molar mass. I'll put moles of Sb2O3 down here. Ooh, that's an ugly 3. So that those units cancel. Molar mass by definition is always 1 mole. And then up at the top, I'll put the molar mass, which is 291.52 grams of Sb2O3. I see these units cancel, these units cancel. I'm left with grams, which is what the problem asked for, and we are ready to plug it into our calculators. 3.5 multiplied by 1, which is, I can skip that, multiplied by 291.52, divided by 3. That gives me an answer of, I'm going to put it over here, 340 point, let's see, we'll go with 1 decimal place again, 0.1 grams of Sb2O3. Can seem a little bit overwhelming. I totally understand that, but it just takes a little bit of practice. And just like everything else kind of felt a little bit overwhelming, you'll get the hang of it. I promise. Okay. If I could leave you with one little bit of parting advice before I see you tomorrow, that would be the bridge between different substances is always mole to mole. Always. If you want to go from one substance to a different substance, you have to cross the bridge, if you will, of mole to mole. I can never, ever, ever go from grams of something to moles of something else, or vice versa. And so if the problem asks me to do that, go from moles of one thing to grams of something else, or vice versa, I know that I'm going to have 2 fence posts. There's just no way around it. And making the roadmap is important. We'll get more practice as we go. So I think to conclude, I'd like you to try, if you have time before the bell rings, try out number 6. Okay, similar type problem as the ones before, but try this one out. Okay, and then when you get that done, we'll call it a day. Thank you for your participation, and I will see you all tomorrow.